is question number 6 of January 2023, paper 1. So for part A, the question has asked us, given that bracket 8 plus 3x to the power 1 by 3 can be expressed in the form of p bracket 1 plus qx to the power 1 by 3, where p and q are constants, find the value of p and the value of q. So for part A, they have given us a expression which is 8 plus 3x to the power 1 by 3. So it is 8 plus 3x to the power 1 by 3. They have asked us to express it in this form: p plus 1 plus qx to the power 1 by 3. 1 plus qx to the power 1 by 3. If you look at this expression that we are given, 8 plus 3x to the power 1 by 3, this is actually in the form of a plus bx to the power d, where a is not equals to 1. And when a is not equals to 1, and when we have to bring a 1 in the expression, as you can see in p bracket 1 plus qx to the power 1 by 3, we actually try to bring the 1 by using this. So when a plus bx to the power d, when a is not equals to 1, at first we take the a out, and as there is a common power over the expression, so we write that over a. And then the bracket, it's 1 plus, and this would turn into b by a. So b by ax to the power d. So for the given expression, 8 plus 3x to the power 1 by 3, where a is equals to 8, so at first I will write 8, and d is equals to 1 by 3, so I'll write 1 by 3, bracket 1 plus b is 3 here, so I'll write 3, a is 8, x to the power 1 by 3, and 8 to the power 1 by 3 is actually cube root of 8, which is 2, and bracket 1 plus 3 by 8x to the power 1 by 3. And they have asked us to express it in the form of p plus p bracket 1 plus qx to the power 1 by 3. So if you look at this, so p bracket 1 plus qx to the power 1 by 3. So p would be equals to 2, and q would be equals to 3 by 8. So this is the answer for part A. For part B, hence, means we have to use the previous part of the question, previous answer of the question. Expand 8 plus 3x to the power 1 by 3 in ascending powers of x up to and including the term in x squared. So we only have to expand till we get x to the power 2, expressing each coefficient as the exact fraction in its lowest term. So we already got from part A that 8 plus 3x to the power 1 by 3 is equals to 2 bracket 1 plus 3 by 8x to the power 1 by 3. And this is in the form of a to the power d bracket 1 plus b by ax to the power d. This is the form I like to express my expressions in. So when something is in this form, and when you are asked to expand, so when something is in the form of a to the power d 1 plus b by ax to the power d, and you are asked to expand, the format of expanding would be a to the power d bracket 1 plus d multiplied by b by a x plus d multiplied by d minus 1 divided by 2 multiplied by 1 multiplied by b by ax whole square. And we are asked to expand till x to the power 2. So we can expand up to this. So for a to the power d is equals to 2 in our expression. And it would be 1 plus d is, okay, let me write this here. So 1 plus 3 by 8x to the power 1 by 3. So d is 1 by 3 in our expression. So let me just change the brackets. So this will be this. So we're 1 by 3 and b by a is 3 by 8x plus 1 by 3 multiplied by 1 by 3 minus 1 divided by 2 multiplied by 1, or you can write it as 2 factorial, and b by a is 3 by 8x whole square, and brackets will be closed. You can also give a bracket here. So the answer for this would be, at first I would write 2 brackets 1 plus the 3 will get cancelled, so this would be 1 by 8 x. And if you put this in your calculator, 1 by 3 multiplied by 1 by 3 minus 1 divided by 2 multiplied by 3 by 8 x whole square, then you'll get a value of minus 1 by 64 minus 1 by 64 x squared. And now if you multiply this, so this would be 2 multiplied by 1 is 2 plus 2 multiplied by 1 by 8 is actually 1 by 4x minus 2 multiplied by 1 by 64 is 1 by 32x squared. This is the answer. So they have said that expressing each coefficient as an exact fraction in its lowest term. So lowest term means that when you have a fraction, like 4 by 8, this is a fraction, but this is not in its lowest term. The lowest term would be 1 by 2. So the numerator and the denominator should not be divisible to each other. So for part C, we are asked, using the expansion found in part B with a suitable value of x, show that cube root of 9 is equals to 599 by 288. So we have to actually at first make cube root 9 here. So here, if you look at the expression that was given to us, which was 8 plus 3x to the power 1 by 3, this thing can also be written in this form. So cube root of 8 plus 3x, cube root of 8 plus 3x. And if you look at this, we actually have to make cube root 8 plus 3x equal to cube root of 9. And then we need to find the value of x and put that value of x in this expansion that we just got from part B. And we need to get this value, 599 divided by 288. So indirectly, we have to get the value of cube root of 9. So at first, we have to assume that if we want to make cube root of 8 plus 3x equals to cube root of 9, then what will be the value of x? So we have to assume that they are equal. So it would be 8 plus 3x. The cube roots will get cancelled out. So it will be 8 plus 3x equals to 9. So 3x equals to 1. 9 minus 8 is 1. So x equals to 1 by 3. Right? So now, if I put this in our expansion of part B, so we know that cube root of 8 plus 3x is equals to 2 plus 1 by 4x minus 1 by 32x squared. And if I substitute x with 1 by 3, then, okay, let me change the bracket. So it would be 8 plus 3, 1 by 3 x, and 1 by 3x is substituted by 1 by 3. And 2 plus 1 by 4 multiplied by 1 by 3 minus 1 by 32 multiplied by 1 by 3 whole square. So if you put all this in your calculator, then this will become cube root of 9. The 3 will cancel, and 8 plus 1 is 9. So this will be cube root of 9. And if you put this part in your calculator, this would be actually 599 by 288. So we have shown what they have asked us to show. So thank you.